Hello everyone. I'm academician Dr. Lilia. Welcome to Science and Me YouTube channel. Quantum biology, where life meets the bizarre world of quantum mechanics. Imagine tiny particles in living organisms defying the everyday laws of physics, existing in multiple states simultaneously and influencing biological processes in mysterious ways. This is the fascinating realm of quantum biology, a burgeoning field bridging the gap between seemingly disparate worlds. In this video, we'll embark on a captivating journey into the microscopic world, exploring the potential role of quantum phenomena in biological systems. What is quantum biology? At its core, quantum biology bridges the gap between the classical laws governing our everyday world and the quantum laws that reign over the microscopic domain. It applies these quantum principles to biological systems, seeking to explain processes that classical mechanics fall short of. In essence, quantum biology explores how the principles of quantum mechanics, typically associated with the microscopic realm of atoms and molecules, play a role in various biological phenomena. These principles include superposition. Imagine a molecule existing in multiple states simultaneously, like a coin spinning in the air before landing. This quantum weirdness might play a role in enzymatic reactions, speeding them up dramatically. The ability of a particle to exist in multiple states simultaneously, defying our classical understanding of either or. Tunneling. Particles defying classical barriers and appearing on the other side, seemingly through thin air. This phenomenon might explain how electrons navigate complex pathways in photosynthesis, capturing light energy. Entanglement. A bizarre phenomenon where two particles become linked, sharing an instant connection regardless of distance. Two particles linked in a way that their fates are intertwined, regardless of distance. This could be relevant in bird navigation or the communication between DNA strands. Where does quantum biology play a role? Several key biological processes are suspected to have a quantum undercurrent: photosynthesis. The remarkable efficiency of light-to-energy conversion in plants might involve quantum coherence, where light energy gets funneled to reaction centers with minimal loss. The remarkable efficiency of light capture in some organisms might involve quantum coherence, where light waves work in unison to enhance energy transfer. Magnetoreception. Birds, insects, and even some mammals possess an uncanny ability to sense Earth's magnetic field. Quantum effects in specialized molecules are thought to be responsible. Smell and vision. The intricate dance of molecules in our noses might involve quantum tunneling, allowing us to detect subtle scents with incredible accuracy. The incredible sensitivity of our sense of smell and the efficient light capture in vision might involve quantum tunneling, allowing molecules to interact despite physical barriers. DNA repair. Some theories suggest that specific DNA repair mechanisms harness quantum effects to achieve high fidelity and speed. The delicate process of repairing DNA damage could benefit from the error-correcting properties of quantum computing, potentially leading to new therapies. The quest for answers and future implications. While the evidence for these quantum effects is still emerging and under intense scrutiny, the implications of its confirmation are staggering. It could rewrite our understanding of fundamental life processes, paving the way for novel drug design. By targeting and manipulating quantum processes in disease-causing molecules, we could develop more efficient and precise treatments. Bio-inspired quantum technologies. Harnessing the principles of life's quantum tricks could lead to breakthroughs in areas like solar energy storage, nanomachines, and ultra-sensitive sensors. A deeper understanding of life itself. Unveiling the quantum underpinnings of biology could offer a whole new perspective on the essence of life and its remarkable properties, but it's not all smooth sailing. Quantum biology faces significant challenges. While the evidence for quantum effects in biology is growing, the field is still in its early stages. Experimental challenges and the complex nature of living systems pose significant hurdles. However, advances in technology and theoretical frameworks are paving the way for exciting discoveries. Technical difficulties. Observing and manipulating quantum phenomena at the biological level is incredibly challenging and requires specialized equipment and expertise. Theoretical unification. Integrating established biological knowledge with quantum mechanics is no easy feat, requiring creative models and frameworks. Potential hype. Sensationalizing unconfirmed findings can hinder scientific progress and create unrealistic expectations. Quantum biology is an exciting frontier, pushing the boundaries of our understanding of life and its underlying principles. While still in its nascent stages, the potential implications are vast and could revolutionize various fields. However, a cautious and rigorous approach is crucial to navigate this challenging yet immensely rewarding scientific adventure. Quantum biology opens a door to a deeper understanding of life, revealing the hidden language of nature operating at the quantum scale. As we unravel these mysteries, the potential applications are vast, ranging from new medical treatments to bio-inspired technologies that harness the power of the quantum world. This video is just a glimpse into the fascinating world of quantum biology. What other phenomena do you think might be explained by quantum mechanics? Share your thoughts in the comments below and let's continue this exciting exploration together. Dear friend, I hope you benefited from the video. Thank you for watching today's video. If you enjoy content like this, please don't forget to subscribe to my channel and click on the notification bell to stay updated with new videos. Also, if you liked it, be sure to leave a like and share your thoughts in the comments. Looking forward to seeing you again with new videos. I can't wait to bring you more knowledge from the enchanting world of science.